Hi, this is lesson 1.2, solving multi-step equations. This is on page 12. On this video, you will learn how to solve multi-step linear equations using inverse operations. Now remember, you learned one step in the last lesson. We're on multi-step today. You will use multi-step linear equations to solve real-life problems, and you will learn how to use unit analysis to model real-life problems. To solve a multi-step equation, a core concept, you need to, step one, simplify each side of the equation. That means combine like terms and so on. And then step two, then use inverse operations to isolate the variable. We're going to practice that on a couple of these examples here so you can see that at work. So in this first sample question, solve 2.5x minus 13 equals 2. Let's check, can we simplify each side of our equation? We always want to try. Can I take 2x and subtract 13? I hope you're sitting there saying, no, Mr. Lemansky, you can't because they're not alike, and you'd be right. So I tried simplifying there. And can I simplify 2? And I hope you're saying, no, you can't. So we always try to simplify. You notice here, if necessary. So we tried, we can't. So now, step 2, use inverse operations. So here comes, when I talked about onion, think about the onion again. X is the center. The multiply by 2.5 is the next closest thing to x. That's the next layer. The minus 13 is the outside layer. So I have to peel away from outside in. I got to get rid of the minus 13 first. So that's why you can see here they're adding 13 to each side. And when you add 13 to each side, minus 13 plus 13 cancel. You get 2.5x on the left and 2 plus 13 is 15 on the right. Okay, next step. X is the center of the onion. The 2.5 is the next layer. I got to get rid of the times 2.5. How do you get rid of times 2.5? And you can see here in the book, they are dividing each side by 2.5. 2.5 divided by 2.5 is x, and 15 divided by 2.5 is 6. So the solution is 6, and then you should check it. I should be clear, I should see your work in this manner on your paper. I should see each step, okay? Maybe because of that, I won't just copy this next problem out of the book. I'll actually write it out and we'll do it together. So I rewrote the problem from scratch. So step 1, let's try to simplify. Can I simplify negative 12 on the left? And no, can't do anything there. But look at on the right side. 9x minus 6x, I can combine those together. That's 3x. Let's rewrite this into 3x plus 15. I simplified. Okay, so now I'm thinking about my onion. X is the center, times 3 is the next layer, plus 15 is the outside layer. I got to get rid of plus 15, so I'm going to take away 15 from each side, and that would give me 3x equals negative 27, and then you can divide each side by 3 to get rid of the times 3, and x would equal negative 9, and then I should check my answer. If I plug negative 9 in here and there, this side should equal negative 12. If it doesn't, I know I have a mistake. You do not have to draw the onion on your homework. I'm just doing it here because I want to make sure you're doing this in the right order, because you've heard me tell you this in class. If you do not solve in the right order, you're not going to get the answer right. So the order is important when we're working with different operations. Let's go to the bottom of page 12 and have you try these 3. Again, that's great for me to ask on an audit, hey, I had you do this in the video and write it down. So go ahead and try those 3 and then start the video and I'll show you what the correct work would be. Okay, I'm back. So in the first question, N was the center of the onion, the negative 2 is the next layer, the plus 3 is the outside layer. So take away the 3, divide by the negative 2, N is negative 3, and then you can check that to make sure it's correct. Here, in the second question, C is the center of the onion, the half is the next layer, the minus 11 is outside. Got to get rid of minus 11 first then. Add 11 to each side. That would give you half C equals negative 10. To get rid of times half, you can divide each side by half. I know that looks kind of funky, but it's correct. Divide each side by that half, and C would equal negative 20. Make sure you put, if you're using a calculator, make sure you put this in your calculator correctly. You got to enter negative 10 divided by open parentheses 1/2 close parenthesis if you are using a calculator. I better star that. Check that on your calculator. You ought to be getting negative 20. And then the final question, do you notice we can simplify right there? Combine those together. Negative 12x plus 12 equals 18. So take away the 12 first because that's the outside layer of the onion. You got to get rid of plus 12. Take it away. And then from there, divide by negative 12, and x is negative half, and you can check it. This next heading is called Using Structure to Solve a Multi-Step Equation. When it says using structure, I guess I'd be more specific. This involves the distributive property. Okay? When you have the distributive property, you normally have two options to solve the problem. We will walk through each right now. Okay? Here's the first method of solving a multi-step problem that involves the distributive property. The first method, I would just say, is to simplify first. Let's look at that. So what they're doing here is they're going to simplify. They're going to distribute 2 times 1, 2 times the opposite of x. So you can see 2 times 1 is 2 right here. 2 times the opposite of x is negative 2x. We still have the plus 3 equals negative 8. Now combine like terms. Positive 2 positive 3 would get you positive 5. So that's where we're getting the negative 2x plus 5 equals negative 8. And now that should look pretty easy from there. My onion, let me draw it up. I have to get rid of the outside layer. I got to get rid of the plus 5 first. So take away the 5, which gives you negative 2x equals negative 13. Now you can see they are dividing each side by negative 2. And when you do that, we will get x equals positive 6.5, and you can check it. So that's one method of solving with the distributive property. Just simplify first. Now, some problems, it is easier. It says here, method 2, another way to solve is by interpreting the expression 1 minus x as a single quantity. So you may be like, what's that, okay? I would just call this this is just using the onion method. Pretend 1 minus x is the center of the onion. If 1 minus x is the center of the onion, the times 2 is the next layer, and the plus 3 is the outside layer. Just start peeling one layer away at a time. So I got to get rid of the plus 3 outside layer first. So take away 3, you can see that here. And when you take away 3, you get 2, and then parentheses 1 minus x equals negative 11. Now remember, the 1 minus x is the center of the onion, so now the next layer is to get rid of that times 2, and to get rid of times 2, you can see they're dividing each side by 2. And when you do that, times 2 divided by 2 cancel. Now you have 1 minus x on the left, and negative 11 divided by 2 is negative 1.5. And now, since we got rid of those layers, now I want to solve for x. So I'm going to start a new onion now. X is the center, and the positive 1, that's a positive 1, is the outside layer. So take away the 1, which leaves you negative x equals negative 6.5, and then divide each side by negative 1 to get rid of the negative in front, and you get positive 6.5, and you notice you're getting the exact same answer. Some problems it's easier to simplify first. Some problems it's definitely easier to use, I would call that onion method. just to peel away one layer at a time. Just solve for the expression first, and then solve for x after. I would like you to try 4, 5, 9 here just to speed things up a little bit. So pause the video and try those 3, and then we'll look at each one. Okay, we're back. So for number 4, I decided to just simplify number 4 first. You could have used the onion method, but I distributed first. So I'm simplifying. 3 times x and 3 times 1, you can see here, I have 3x plus 3 plus the 6 equals negative 9. Now combine your like terms. 3 and 9 combine, and, I'm sorry, 3 and 6 I meant to say combine and give you 9. So now I have 3x plus 9 equals negative 9. Now I'm thinking about my onion, the outside layer's plus 9. So take it away, and then divide by 3. There's your answer. Make sure you check it so that this side works out to negative 9. I checked it, and it did. Let's go to 5. Now, number 5, I decided to use the onion method in this one. I decided to say, okay, there's the center of my onion. I have to get rid of the times 4, and I have to get rid of the plus 5, but I got to get rid of the plus 5 first, positive 5. So take away 5. So now 10 equals 4 times 2d minus 3. The next layer of the onion, get rid of times 4. Divide each side by 4. Those cancel. And now, when I get to here, I can start a new onion and solve for d. Add 3 first. Divide by 2. There's my answer. I took my calculator and checked it. You just got to double check when you plug it in. Does it give you a true statement? And then the next question. I didn't know if you had noticed this, so I thought I would do it this way on my video. Do you notice that I have 5 of 3 minus x plus 2 of 3 minus x? I can add those together. They're the same. I have 5 of these and 2 of these. So I have 7 3 minus x's equals 14. And now I'm going to use the onion method. There's the center. 7's the outside layer. Let's get rid of times 7. Divide each side by 7, which gives you 3 minus x equals 2. And now I'm going to create a new onion. X is the center. I got to get rid of plus 3. Positive 3. Take away 3 from each side. That leaves you, don't forget about your sign here, that leaves you with negative 1x equals negative 1. So divide each side by negative 1, and you can see you're going to get positive 1. And then check and make sure it works. If I put a 1 here and a 1 here, this statement should work out to 14, and it did. Let's talk about solving real-life problems. Here would be a sample, modeling with mathematics. Use the table on the right here to find the number of miles x you need to bike Friday, so there's my unknown. How many miles I have to bike Friday so that the mean number of miles biked per day is 5. So the first thing, maybe in our notes we should get, the word mean is average. So they want me, after a week of biking, to average 5 miles biked a day. So let's think about that. How am I going to find out x? Well, the key word here is average. How do you find the average? I know you've been taught this. If I add all these numbers up, and you notice there's 5 of them here, 1, 2, 3, 4, 5. If I add those 5 numbers up and divide by 5, I'm supposed to get an answer of 5. Well, let me write that out. If I add up all of these numbers, 3.5 plus 5.5 plus 0 plus 5 plus x, and I divide by 5, I'm supposed to get 5. Okay? There's my equation. Let's simplify. I can combine all of that together. 3.5 plus 5.5 plus 0 plus 5 is 14. So 14 plus x divided by 5 would equal 5. Okay, now it's onion time. X is the center. Do you remember from earlier in the year, on a fraction bar, you must do everything on the top first and the bottom next. Divide at the end. So my next layer is the positive 14. The divide by 5 is the outside layer. I got to get rid of divide by 5 first. That's why we're going to multiply each side by 5 next, which you see here in the book. They're doing the same thing. So divide by 5 and times 5 cancel. 14 plus x equals 25. And then I can take away 14, and it looks like I'm getting x equals 11. Let's just make sure that makes sense. If I'm supposed to average 5 miles a day, it's 11 miles. Well, let's think. We did not bike at all Wednesday. So we probably need double miles Friday. What's double 5? 10. That's pretty close to 10. That seems like a pretty reasonable answer. So 11 miles would have been my biking distance, it looks like Friday. Okay? Unit analysis to solve or model real-life problems. Let's talk about that next. When you write an equation to model a real-life problem, you should check that the units on each side of the equation balance. In our last example, think about it. We had miles on top, the fraction bar meant per, and days on the bottom. Okay, so we had miles per day on the left. Well, the answer was 5 miles per day. My units matched. So when we solve these problems, our units should match. So let's look at this one. Your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for the costumes and props. After paying back the loan, the club had a profit of $100. How many people attended the play? So that's my unknown right there. I don't know how many people attended. So let's think for a minute. They told me my profit. They told me how much we had to spend. They also told me what they charged. So right now I'm thinking, okay, I know my profit, I know what I spent, and I have an idea of what I charged. So I'm thinking profit equals income minus expense. Now, I know you've learned this before, but let's just review it. Let's think real quick just to make sure you understand this. If you open a lemonade stand and you collect $10, people paid you $10, that's your income. Let's say it cost you $3 to set everything up, to buy the lemonade, to buy the little Dixie cups, whatever. You spent $3. Does it make sense your profit would be $7? You collected 10, you spent 3, you made 7. Okay? We just have to fit this to this problem. So let me see. My profit was 100. What was my income? I charged $4 per ticket times the number of people that came. Like if 100 people came, 4 times 100 would tell me how much income I had. What were the expenses? Well, it cost me $400 for these costume and props. Okay, there's my equation. Let's solve it and check it. So, onion time. There's the center. There's my layers. I have to add 400 first. So 4x equals 500. Divide by 4, and it looks like my answer is 125. That means 125 people attended the play. That was what I was looking for. How many people attended? Now, let's check and see if the units made sense. That number represents dollars. 4 represented dollars per person, so I'll put dollars over people. X represents how many people bought tickets. And 400 was dollars. Let's see if my units work. Well, you see how I'm multiplying here? I have people on top and people on the bottom, so the people cancel. It looks like I'm left with dollars equals dollars minus dollars. Well, if I take dollars minus dollars, I'm going to get dollars. My units match. That's what they mean by unit analysis. your units, the left unit should equal the right units at the end of the problem, or you know you have a mistake in your work. I'm going to stop the video there. If you have questions, make sure you ask in class.